Hey there, folks. Welcome to our third and final enzymes lecture. As you guys will see, we're on enzymes 3, and today our focus is going to be on what we call enzyme graphs. Okay, they are energy versus reaction progress graphs, and we're not just going to learn how to label them, but we're also going to learn what they mean, because in any life sciences course you take and in any chemistry course you take, like you will be taking next year, these graphs are going to be coming up again and again and again. So this might be the first time you're seeing them, but I can promise you it won't be the last. So the first thing I want us to look at is basically what we've learned so far, okay? And what we can see here is this is our enzyme, right? Our big orange enzyme is right there. And right above it is the substrate. Right there in green, right? And what goes on, right, in a chemical reaction is that you have a substrate that binds to the enzyme. And if you guys remember, the substrate it's like the key, right? And the enzyme is like a lock. Okay? That is, right? This enzyme is very specific, right? It's only really going to bind to one substrate, okay? And that's something I need you guys to really understand, is that we have our key and our lock, and this enzyme is really only going to bind to one type of substrate at its active site, okay? And remember, that active site is right in there that I'm shading yellow, okay? So our second step is that we actually have that substrate which has bound to the active site of the enzyme. And as you guys can recall, this is actually known as the enzyme substrate complex. Okay, and it's here where chemical reactions occur. And this should make sense, okay, because you're not going to have a chemical reaction unless the substrate is bound to the enzyme, right? It's not going to happen on its own. And then lastly, what you guys can see is that we have our product right there. And after the chemical reaction has occurred, the product pops out and goes elsewhere in the cell. Okay, so our three steps. We have a substrate that is looking for an enzyme to bind to. We have the enzyme substrate complex where the chemical reaction occurs. And then we have our product being released from our enzyme. Awesome. So, getting a quick review before we go into learning about these graphs today. All right, remember that the symbol for free energy is delta G. Okay, that little triangle there is a delta symbol, and that we have two types of chemical reactions. We have those that release energy, right? We call these exergonic reactions, and you guys know a whole list of examples of those by now. And we have those reactions that consume energy. Remember, that word consume basically means eat. Okay? And we call those endergonic reactions. All right? And if you guys look over here on the right, I put these two photos again because I thought they were really, really good. And our first one, of course, is about exergonic. And you'll notice that energy is a product, okay, right? Energy is being released. It's not being put into the chemical reaction. And that for endergonic, right, endergonic reactions, you have energy as a reactant, right? Energy is being put in, but it's not coming out, okay? So one last reminder is to say that enzymes increase the rate of the chemical reaction, something else we talked about, and they do this by reducing the activation energy. And this should make sense, right? If there's less energy needed for a reaction to begin, it's going to happen faster, okay? I think that's pretty common sense. So we're first going to look at endergonic. And remember, endergonic, right, is when we're putting energy into the reaction. And I put this image right on top just to remind you that this graph is referring to the chemical reaction that is occurring in the enzyme substrate complex. Okay? So I'm going to zoom in on this just a little bit more to help you guys out there. Okay, so just the purple. So the bottom axis, all right, our x-axis right here, all right, we refer to this, right, the title for this is going to be reaction progress. And of course, this starts at time 0, okay? And the reaction progress just continues that way. And what we're going to be labeling our y-axis is free energy. And you guys know this as delta G, okay? So we have free energy versus reaction progress, okay? And what we're going to be looking at to start with right here, okay? This is the energy of the reactants. So you can put delta G reactants. That's exactly what that is. It's smaller for you guys. Okay. So that box will always be the free energy of the reactants. Okay. And what happens right here, you guys will notice there's this double arrow. And what you're seeing is that this red line, right, it's just going up and up and up and up and up and up. What this red arrow represents and why this red line is going up is because this is the activation energy necessary for the reaction to occur. Okay? And that goes right along with our y-axis, right? As the reaction, with our x-axis, right? Our reaction progress is going forward. The free energy, right? The energy in this reaction is increasing because remember, we have to put some of that energy in originally as the activation energy. Then, as our reaction begins, I'm going to see if I can highlight this for you guys, right? Once there's enough activation energy right here up top, what happens is that you see there will be a little bit of energy go down as we make our products. Okay? But what I want you to note, there's delta G there. Okay? What I want you guys to note is it's that the products here, right? Notice that they're higher than the reactants. The reactants are all the way down here, right? But our products are all the way up there. Okay, what does this mean? Well, when the products are above the reactants, this is an immediate signal that the reaction is endergonic, okay? An immediate symbol. So anytime that you see, right, you have this red line that goes all the way up to the top there. Anytime that you see the products above these reactants, you know it's going to be endergonic, okay? This means that there is more energy in the products than the reactants and that the reaction consumed energy. And again, I think just by looking at this graph, that's really noticeable, right? We started off with a really low amount of energy way down here, right? And we ended up with a really high amount of energy way over there. Now, our exergonic reactions are just the opposite of this, okay? So our graph is going to be labeled the same in that you have reaction progress here, That's going forward that way. You guys have free energy up here. Cool. You have free energy up there. Okay. This is still our reactants. And this arrow, right here, put the same one right there, if that makes you feel better. I'm sure it makes me feel better. This is our activation energy, just like it was in the first graph. But the big difference is you guys will notice that our products are way down here. Right? The energy in our products is way down there. So what happens is that in this area right here, okay, in that area, right, the area between the reactants and the products is a whole gap of energy that is released in this chemical reaction. Okay, that's the energy released. So we can put this into text as when the products are below the reactants, the reaction is exergonic, right? Energy is released. Because products have less energy than the reactants. Cool? And that's basically what this point below is saying. This means that there is less energy in the products than reactants, and that the reaction releases energy. Okay? And that's, again, exactly what we see. We have our reactants here that are way above our products way down there. Okay? And again, it's right here, this thing, right? This is the energy that is released, the space between the reactants and the products. This is the energy that needs to be put in to the chemical reaction for it to occur. That's our activation energy. Okay? And then super lastly, you guys don't even need this slide. Yep, so I'll take this out of your PowerPoint at home. So don't even worry about this guy right here. We'll just X that out. You guys are going to be doing some group practice and independent practice. I know this is a lot thrown at you. And so please, if you have questions, raise your hand. But definitely look at these graphs and digest this before moving on. Okay? Thanks so much for listening, guys, and I hope you really enjoy.